Okay, now let's continue with chapter 4. We're going to do section 4.4, properties of logs. So we're going to talk about the product rule, the quotient rule, and then the power rule for logs. But before that, let's just review what we know about properties of logs. And I'm talking about what we learned in section 4.3. So we know that log of 1 to any base b is 0 because b to the 0 is 1. Now if the base is 10, log of 1 is 0, and if the base is e, ln of 1 is 0. We also know that log base b of b is 1 because b to the first power is b. So in terms of log 10 base 10 is 1, and ln of e is also 1 because ln has a base. So whenever the input and the base are the same, the answer is 1 for the log, okay? And we also know that log base b of b to the x, because b to the x and log base b are inverses of each other, these cancel out and you get x. For instance, log of 10 to the x is x, ln of e to the x is x. And if we reverse that, if it's b log base b of x, that's x, but be careful here, x has to be in the domain of log, which is greater than 0. So 10 log base 10 of x is x. Again, x has to be greater than 0, e to the ln of x. So this we learned in section 4.3. So now the new properties of logs are, the first one is what we call the product rule of logs. And the first thing I want to do before I show you the rule is check with my calculator. Is it true that log 6 equals log of 2 plus log of 3? Well, let's check. I'm doing base 10 because all calculators log base 10, but it should work for any base. So log of 6, it's 0.77815, whatever, it's irrational. Log of 2 plus log of 3. Same exact answer. And we suspect that that's going to be 2 times 3 is 6. Let's try again. Let's try log of 20. Is it log of 4 plus log of 5? Or it could be 2 and 10, or it could be 2 and 10, yeah. So because 20 is 4 times 5. So let's check. Log of 20 is that, and log of 4 plus log of 5 is the exact same answer. So that makes us suspect that log of base b of m times n equals log base b of m plus log base b of n. So if you have a product here, we can split it into sum when it's inside the log, okay? As long as everything is defined and real. This is called the product rule. It works both ways. So in other words, log of 4, log of 5 equals log of 20, and log of 20 is, so going this way, you break it down, going backwards, you condense the log, okay? So expanding, condensing, expanding, condensing. So for example, if I want to evaluate log base 12 of 9 plus log base 12 of 6, so I can write this, since it's a plus, I can write it as 9 times 6, which is, 16. 9 times 16, which is log base 12 of 144, which is 2. Why? Because 12 squared is 144, okay? Or you can write this as log base 12 of 12 squared, and that gives you a 2. And another example, if it says expand as much as possible, and we have log base 3 of 5 times x times y. Again, using the product rule, we can write this as log base 3 of 5 plus log base 3 of x plus log base 3 of y. That's as much expansion as we could do using the product rule. Then we could do next the quotient rule for logs. The quotient rule of logs. Again, let's look at several examples. If you do say log of 2 minus log of 3, does that equal log of 2/3? Well, let's check. We're not saying log of 2 minus 3, we're saying log of the quotient. So if it's a minus, you get a quotient, and be careful, the 3 is at the bottom because it has a minus in front of the log. So log of 2 minus log of 3, that's the answer. Log of 2/3, same exact answer, negative 0.17609, blah blah blah. Okay, so let's try again. Log of 5 minus log of 4, does that equal log? So it'd be 5/4, right? Because again, the negative is in front of the 4, so the 4 goes at the bottom. The 4 goes on the bottom. Sorry, okay. So let's try. Log of 5 minus log of 4, and then log of 4/5, 5/4. And the same exact answer. Okay, so that makes us think that log base b of m minus log base b of n is log base b of m or n. Again, the bottom is what have a negative in front of the log. Okay, always. And you can, again, this is condensing the log, this is expanding the log. Log base b of m over n is log base b of m minus log base b of n. So for example, if I have, say, if I want to expand as much as possible, log of x over 10, where the base is 10. So using the quotient rule, this is log of x minus log of 10. But we know that log of 10, base 10 is 1, so it would be log of x minus 1. Alright, finally, so we've done the product, the quotient. Now the power rule of logs. The power rule of logs. So say I have log of x squared. We know we can use the product rule because x squared is x times x, which would be log of x plus log of x. 1 log x plus 1 log x is 2 log x. So it looks like if I have an exponent, I can times it by the log, or the other way around. If I number in front of the log, I can put it as an exponent. Let's try one more. Let's try an example. Say log of 8. Remember, log of 8 is log of 2 cubed. We suspect that's going to be 3 log of 2. So is it true that log of 8 equals 3 log of 2? Let's check. Log of 8 and then 3 log of 2. That same exact answer, okay? So as a general rule, log base b of x to the r is r times log base b of x. Just be careful. Be careful that this has to be defined. Once you remove the r, like if this was x squared, it's always defined. But if it's x cubed and you remove the find, it's always defined. So you gotta be careful, okay? As long as this is always defined. Okay. So we can expand, say, we can expand log of square root of 2, which is actually, we can write it as 2 to the 1/2, which is the same thing as 1/2 log of 2. Or we can go backwards, like if you have 1/4 log of 7, we can write this as log of 7 to the 1/4, which is log 4th root of 7. Back and forth, okay? Alright, so number 40, page 359. 40 from page 359. From page 359, it says expand, use the laws of log to expand the expression. Expand the expression. Log base A of x squared over yz cubed. Log base A of x squared over yz cubed. Well, we can write this as log base A of the top minus log base A of the bottom. That's what I used. I used the quotient, okay? I used the quotient rule. Now the 2, you know, x squared is always positive. So if we put the 2 here, log base A of x, x could be positive, could be negative. We don't know, but when you square it, it's positive. So you need absolute value because remember, logs, domain of log is all positive real numbers. So if you have an e power and you put it up front, that's like a protection for the x because it's always positive when it's x squared. But once you remove that, x to the first power could be positive, could be negative. How do we guarantee it's positive? We put the absolute value. Minus. Now this is using the product rule, log base A of y plus log base A of z cubed. Remember there's a plus and then the negative is up front, so you're going to distribute the negative. So 2 log base A absolute value of x minus log base A of y minus log base A of z cubed. Now this has an exponent of 1, so it's good. This has a 3. Remember z cubed could be positive, could be negative. So when you remove the 3, it's still z could be positive, could be negative, so it doesn't need protection. It's already protected. Z cubed has to be positive, otherwise the log would not be defined. So all we have to do here is put the 3 up front. And no absolute value needed unless you remove an even power. Once you remove an even power, you must put an absolute value. Number 44. Page 359. Again, expand as much as possible. Ln, the log of 3x squared over x plus 1 in parentheses to the power 10. So again, we're going to do the quotient rule first. Ln of the top minus ln of the bottom. Using the product rule, this would be ln of 3 plus ln of x squared minus, using the power rule, again, since it's an even power and you want to remove it, we need absolute value to make sure that x plus 1 is always positive. And the 2, again, is an even power, so we remove it. Again, we need an absolute value for x because it's an even power. And that's it. Okay, number 48. Log square root of x square root of y square root of z. So let's remove the square root and put power. So that outermost one is going to be for everything as 1/2 x here, then this one would be y 1/2 and then z 1/2 at the bottom. Okay, so I removed every square root and put a 1/2 instead. So now if you start inside out, you're going to distribute that power. So it will be y to the 1/2, z to the 1/4, because 1/2 times 1/2 is 1/4. And then x, and then 1/2. Now distribute this power, so it would be x to the 1/2, y to the 1/4, z to the 1/8. And now we can do the product rule. Log x to the 1/2 plus log y to the 1/4 plus log z 1/8. And now each power comes up front. So it would be 1/2 log x plus 1/4 log y plus 1/8 log z. And that's as much as we saw. If you go back here, z to the 1/2, it has a square root, y next to it, then 1/2 for y, z to the 1/2 right there, and then x, y, z to the 1/2, they all have 1/2 on the outside because it's a square root for the whole thing. Okay. All right, number 54 from page 24. 54, I'm sorry, page 359. Page 359. It says use the laws of logs to combine the expression. So we want to condense the expression. So we're doing opposite to what we were just doing. X squared minus 1 minus log base 5 of x minus 1. So this, it's a minus, so that's quotient rule backwards. So the positive log on top, the negative one on the bottom. Now we can reduce this because x squared minus 1 can be factored to x plus 1, x minus 1. So it end up with log base 5 of plus 1. So you always need to reduce your fraction no matter what. 56, 2 parentheses, log base 5 of x plus 2 log base 5 of y minus 3 log base 5 of z. They want us to expand, to condense this. So distribute the 2 first. So it would be 2 log base 5 of x plus 2 times 2 is 4 log base 5 of y minus 2 times 3 is 6 log base 5 of z. Now this has to go back as an exponent. Leave the negative alone. Log base 5 of x squared plus log base 5 of y to the 4 minus log base 5 of z to the 6. And now write it as a single log. Every expression that has a positive in front of the log goes in the numerator. Y to the 4 goes in the numerator. Z to the 6 has a negative. It goes at the bottom because of the quotient rule. Okay, so it's x squared y times y over z to the 6. Here's another one. Condense into a single log. 2 log of x minus 3 log of y plus 4 log of z minus 5 log of w. So we start out by putting the numbers back as an exponent, leave the negative sign alone. So it would be log of x squared minus log of y cubed plus log of z to the 4 minus log of w to the 5. Once we remove the numbers from in front of the log, then we know it's going to be a single log with a quotient. The x squared, because it has a plus in front of the log, it's on top. Y cubed negative on the bottom. Z4 has a plus on top. And then W5 on the bottom because it has a negative in front of the log, thanks to the quotient rule. Okay, one last thing from this section is what we call the change of base formula. Change of base formula. You know, most calculators have only log base 10 and ln. So what if I want to do, say, log base 2 of 8? Well, we know this is 2 because 2 cubed is 8. Okay, but I don't have a key up front that gives me log base 2. Well, what you can do, there is actually, if you have the advanced graphing calculator, there is a log base key, which if you go to math and then go up, okay, math and then go up arrow, you can set log base, click on that, and it tells you what the base is, and then you put 2 and then the 8 for the input, and there's the answer. Now of course we don't need the calculator for this because 2 cubed is 8, but we would need it if we have, say, log base 2 of 5. 2 to what power is 5? Good luck. Okay, so you can use this. You can go to math, upward key, log base, hit that, and then base 2, and then 5. And there's another way of doing this, by doing all that work. It's called the change of base formula. You could do this as log of 5 divided by log of 2, and it's going to give you exact same answer. Or you could do ln of 5, ln of the input divided by ln of the base. Either will give you the same answer. That's called the change of base formula. You can change the base to base 10 or base e, and it would use the quotient, and it's going to give you the answer. Okay, so the change of base formula, if you have, say, log base b of x, you have two choices. You can do log of x over log of b, or you can do ln of x over ln of b. I'm not saying logs is ln of x. They're totally different. I'm not saying log b is ln of b. They're totally different. All what I'm saying is the ratio of log x to log b is the same thing as ln of x over ln of b, which is log base b of x. Just like 1/2 equals 2 over 4. 1 doesn't equal 2. 2 doesn't equal 4, but 1/2 does equal 2 over 4. Okay, same concept. So on the test, if I say use the change of base formula, sure, to do, say, log base pi of e, for instance, you have two choices. If you have the calculator, sure, you could just type it in, which is fine. The calculator, I'm not gonna stop you from using it, but make sure you know how to use it. So log base pi, second that key, and then e, second division sign will give us e, and then hit enter, and there's the answer, 0.8. And I'm going to tell you how many decimal places. So let's just do 4.8736. So roughly 0.8736. If you don't have that key, don't panic. You can just do ln of e over ln of pi, or you could do log of e over log of pi, either or. So either one, you're going to do 0.8736, 0.8736. Okay. All right. And the next thing, true or false, I have it that you want to do page 360, number 76. That's for your homework. Okay. And that's it for 4.4. So we'll see you in 4.5 soon.